Hello everyone and welcome to the Introduction to Git and GitHub workshop. This is hosted by Pranay from NUS High. And this workshop so I'll pass the time to Pranay now and he'll start the workshop. Yeah, thank you.
Okay, so hello. I'm Pranay from NUS High, as Yiping already said. I'll be covering what the hell Git and GitHub are and basically how you can use them in a general capacity for collaboration and version control. So, hold on. So basically, what are Git and GitHub? Well, basically GitHub is a tool for code collaboration and code storage, while Git on the other hand is a version control system. So mainly it stems from the fact that we need code collaboration in our systems. So yeah, I'll be covering why Git and GitHub are needed that much nowadays. So, I mean, certainly when we start off computing, we all start with like working on our own. We start working with idle, we start working with the Node.js console, we start working on stuff on local drives. So it's like you store it on your local computer, but then how is someone else who wants to access it going to use it as well, right? So it's more of that when you go into a larger company, if you go into like any sort of location where you have to work on projects, which is a team project. It really your code collaboration skills need to be there. So I mean, there's tools like Code Collab, there's tools like Code with Me, but a lot of the issues that come with them are still present nowadays. So yeah, basically it's not sustainable to just do all the code on your own drive and then share it with the other person, and the person makes a change, and the person shares it back to you, and then you make the change, and so on and so forth. So basically, in most projects, you'll have to create a product in a group, like in a company, in a volunteering organization that where you have to code. And so it's ideal for us to collaborate on code, right? So basically, how is code collaboration originally done? Well, back in the good old days, computers were connected to a single database system. So that would be like you have like 10 or 9 computers, and then they're all connected to this one thing that we used to call a computer, which is the entire database, and that's where they stored everything. That was where most of the computations took place. So yeah, that was like the main location where everything actually happened. And that way, if you made a change, everyone else would see that change immediately. And that's something quite amazing about like the older ways of computing, because it was way faster. But the problem was it was not very portable, because obviously you're not going to use data. You're not going to sit in one location and access a database. At least not nowadays with remote working and everything. So that's why when cloud computing came along, it became a huge revolution, because it's a similar concept, but you're not keeping the database on your local in your local like location, right? You're keeping it online, and so it's become much more easier for you to access that data with servers and everything, with Firebase, with Superbase, with other different types of systems that allow you to access databases. So it's now clear that you can just use code as data, just store it there. And now you can just access that whenever you want. So yeah, there's 4 different ways in which we usually collaborate. When we start out, we usually use like social networking sites like WhatsApp, Discord, sometimes even Telegram. I'm not sure if people use Telegram, but yeah. So it's basically like you either put the code in the message using the monospace thing or something, and then or you attach files. So like let's say I made a change in the Python file, then I'll send that Python file to my friend. My friend will download it to his own computer, run that, see whatever he can introduce into the code, send it back to me, and then I will download it again. So it's a tedious process. It's not very safe. The codes are not easy to share, but of course it's great for beginners, because you don't have to get used to any new technology to use it. Then there's like Google Drive, since Drive introduced this Drive for Desktop plugin, and now you can, if you write anything, like if you create documents and you store it on Google Drive, it will automatically update onto Google Drive. So if you access the shared with me folders and you make some changes there, and it will automatically reflect on Google Drive. So it's the pros that it's very real time and teammates can access your code easily, but the cons are it will probably fry your computer. And by that I mean like like it would take so much because you just go to different files all the time. In coding, you don't really like stay in one file all the time. You'll be making changes to multiple files, at least in larger scale computing, which is where all these code collaboration things actually necessitate. So when we have a larger file system, it becomes tedious for the Google Drive desktop plugin to just continuously update and update and update and update. So ideally, it would just like your RAM would just chalk up a lot, and then at some point you may not be able to actually make it work. Then there's Git and GitHub. So this I'll be elaborating on ahead, but it's basically like a system similar to the social networking sites. Like it doesn't automatically update and it doesn't fry your computer, but it's of course it's not real time. So it's easier for others to access your work, and it's like you just have to do like one command to access another person's work, and to push your work, you just have to do two commands. It's really like easier for you to use like Git and GitHub compared to social networking sites and Google Drive. And the most recent into this foray was live sharing and Code with Me. So live sharing was a new plugin that was introduced in VS Code. VS Code being Visual Studio Code, which is the integrated development environment. I'm not sure if you guys have used it before, but it's like one of the most used IDEs in the world. So VSC, IntelliJ, PyCharm are like JetBrains IDEs. They're also pretty far used, I guess. Like people use it a lot. So it's like these plugins allow you to access these IDEs like their Google Docs. So like let's say I'm going to be the host, right? And then I send my request to some other person. Then that other person can just see what the entire IDE that I've opened up, and they can make any changes they want. It's very easy actually, and it's completely real time. But the problem is because firstly, again, you're using multiple files. Secondly, it needs to make sure that whatever changes you're making are reflecting quickly onto the other person's laptop. So if you're working with a team of more than two people, it becomes a big problem. So it's again, it will probably fry your computer, and there's a higher chance of it frying your computer. So by frying your computer, I mean like taking up all your RAM and not letting you code a lot. Like if you're doing AI, you really don't want that. Yes. So why am I teaching Git and GitHub? Mainly because, well, Git and GitHub are the most used technology, some of the most used technologies in the world. So 93.4% of developers, according to the Stack Overflow survey last year, indicated that they use Git on a regular basis. And anyways, GitHub is used by almost all major companies, Facebook, Google, Amazon. You can find all their organizations on GitHub. So it's best that you start familiarizing yourself with these technologies before entering the industry, before conducting team projects, before like, doing work like which is where you have to like do a lot of collaboration and all. So yeah, now I'll explain a bit about how Git works. Over the time, I'll be switching over between this system and Git itself. So I guess I'll start by showing the terminal. So this is Git Bash. If you install Git, then you'll be able to find this just like searching this, right? So Git Bash. So yeah, this is Git Bash. If you're using Mac OS, you probably don't even need to use this. You can just use the normal terminal for Mac OS. Or if you're using Linux, same thing. You don't need to use this. So I'm just going to show this because I am using Windows. So yeah, this is in Windows terminal. So this is where you get this kind of weird system. Usually this would be your username. Then this is the name of your laptop. This is just an indication of what technology Git Bash uses. And this tilde represents what directory, represents the home directory. So what do I mean by the home directory? I can show you using this. Basically, it's c/user/ whatever your username is. So it's like basically like if you open your file explorer, right? And then you go into this OS and then users and then this thing. This is your this your home directory. So yeah, basically you can use pwd to find out what directory you're in and to access like, okay, if I'm in this directory, where do I go from here? So yeah, anyways, let's say I'm in c/user/Pranay, right? Then I want to create a directory where I can do all the coding. So like a directory is just a folder. So what I can do is I can create a folder called, I'll call it GitHub, I guess. So what I need to do is I'll use mkdir, sorry. Mkdir means make mk directory, dir. So make directory, and let's say I'll name it GitHub, right? So now there's a folder called GitHub, but you need to see what's inside it. So what you can do is you can use cd, which is change directory, GitHub. So now as you can see, it just like created this / GitHub thing, right? Basically, that means that, oh, you were originally in the home directory. Now you're in the home directory / GitHub. So if I were to open this and I search for GitHub on this, let me reload this, then I would find it here, right here. So it's empty right now, and you can also check this using the terminal, using this command called ls. Now, I actually don't know what the full form of ls actually is, but it's just a system that allows you to access, to check what files are locally in your drive. It's like, it just lists whatever files will show up here. Yeah. So ls. It should be empty. Why? Because, well, the folder is empty. So what I can do now is I can create a hello.txt file. So what I'll do is I'll use Notepad for this. Just to give you a foray, I guess. This is a random node. And then I'll save this in this GitHub folder. Wrong folder. So this folder right here, and I'll name it, I guess since I wrote node.txt, right? Now, if I go in here and I write ls, I can see that node.txt appears. It's standard, like node.txt will be accessible. And to see what the contents of node.txt are, I can write cat node.txt. So cat is another command in Linux that allows you to see what the file contents are. So like I can do this and I can see, oh, this is a random node. This is what I wrote in the notepad that you saw. So yeah, basically node.txt will be like your main, the file I'll be editing for most of this, I guess. So yeah, let's say I want to use something a bit more powerful, right? I can use this thing called Visual Studio Code, which I think you may have installed. If you haven't installed, it's fine. You can continue using Notepad. I'm just going to use Visual Studio Code because of the system it adopts for Git. So yeah, how I can access this is I can write code. The code being the Visual Studio Code command line function, and dot meaning this directory right here. So this would slowly open Visual Studio Code. So yeah, basically, I trust this. So then I'll show you how to create a Git repository. So I've shown you a bit of the how the different commands in Git works. So now what I can do is I can create a Git repository. So firstly, let's clear this. Now I can create a Git repository by basically creating this folder called the .git folder. It's a hidden folder which Git manages on its own. So the Git command line tool automatically reads through it and understands like what's going on in this repository. So let's say I did to create that Git repository .git folder. You don't create a .git folder. What you do is you do this. So Git init creates this .git folder for you, and you can access it through the system. Now what I'll do is, now what you can see is that there's this open bracket master thing. This represents what branch you're on. I'll be covering branches later, but basically now I'm in Git, right? So if I now go into Visual Studio Code and type on node.txt, this is standard, right? But if I go ahead and say hello world, then it should have added. So yeah, I completely forgot to put this in track files. Okay, how about this? I'll just cover what the different systems in Git again. So basically in Git, there's 3 different systems in which files can go. So there's the untracked files, the staged files, and the tracked files. So the untracked files are like the files that you added, but Git does not recognize them as part of the repository. Staged files are files that you're ready to commit, or changes that you're ready to commit, but it's not like Git has actually like put them up onto the repository yet. Like, it hasn't recorded it yet. And tracked files are files that you've already committed and they have some changes. or they don't. It's just any of them. It just stays in the track files. So let's say I did git add test1.py, test2.py. So these test1, test2, test3, test4, all the way until test6.pys are all files that I created, and they're untracked files because I haven't added them to Git yet. So to add specific files, I can write git add, then whichever files I want to add. So like yeah, so add allows you to do that. And then after this, what you can do is you can write commit to put that into the track file. So committing is like basically a system where you say, oh, I'm definitely certain that this should be added to the GitHub repository. I cannot move this back. It is in the GitHub repository. So commits are like standard. You can move back in commits if you made a mistake, but it's a tedious process and I won't be covering it here because it's a 1 hour workshop. So yeah, basically like these files are now tracked. So now if I made any change in test1.py, there will be a change that will be recorded here, and I can then stage it and then move it back here. So staging will be like you stage those changes in that specific file, and then you move it back. Then what I can do now is I can also add test3.py, test4.py. So as you know, just commit only takes the test1 and test2.py files. When if I had added test3 and test4.py beforehand, then that committing this thing would just think that, oh, test1.py, test2.py, test3.py, and test4.py should all be tracked. So that's actually why staging exists. Staging exists so that you can define certainly that, oh, these files are definitely the ones that you want to keep in the staging area. So yeah, so I can add test3.py and test4.py using this git add function. So then I guess it's good to explain what the system of Git itself is. So I'm using an analogy that is familiar with some people who may have watched the TV show Loki, but it's like basically you have different timelines that all coexist. Each timeline has its own smaller versions of the timeline. Like it's just like it's called a branch. So like let's say I created a change here and I committed it. Now this is like my local repository. This is the repository that's on GitHub itself. And this is the repository that your teammate has locally on his computer, right? So I'm assuming pair programming here because, showing multiple, more than two people programming at once would be an arduous thing to show on this. So yeah, let's say I introduce a change, which is represented by this red line, right? Then what I can do is I can push this change to the master timeline. This is the secret timeline, which is just the master branch on the remote repository. And then what I can do is I can pull it in, and then your teammate can pull it onto his local repository. So these are two different systems. You have to write git push and git pull to push your changes and pull the changes of your other teammates and everything. So that's like how you can use Git to collaborate. Like if your friend made a change and you made a change, then there's another system that's employed. So I'll show you that as well. So let's say same thing, 3 timelines. We're using only one branch, but you and your teammate both made changes. Yours is represented by the light blue color. His is represented by the dark blue color, right? So what I can do now is I can push, like your teammate may just be like faster and he'll push all his changes to the master timeline, the remote repository, right? Then what are you going to do? If the person has pushed changes onto his repository, then your timeline and his time and the second timeline is very different, right? So how do you merge these two different timelines? So what you do is you just pull, and Git has a system where it reflects these things called merge conflicts. So to show you, okay, I won't show you what the merge conflicts is for now. I'll show you later. But basically, merge conflicts are changes made by both you and an individual to a specific line or specific like set of code within like a file. So a merge conflict occurs like, let's say I created a file called readme.md on my end, and I wrote hello world, and then on your friend created a readme.md and he wrote hello comma world. Then that comma itself will be recorded by Git, and it will say, oh, this is a merge conflict because what are you doing? Do you want the comma or not? So basically, if let's say you fix that merge conflict, then that becomes a merge fix. Like it's basically like deciding which one you want to keep or if you want to keep both. And then after that, you can push this back into the normal timeline. So once you fixed it, it becomes this green color, just for the animation sake. And then your teammate can also pull it, and then he'll also get the new history onto it. So then there comes the concept of branching. So Git has this very cool system called branching, where you can use like if you have one timeline, you can create smaller timelines within the timeline. So you always use this one branch called the master branch. But then let's say you decided to be like eccentric and you created a test branch. And that test branch is where you will create your changes. Then the changes should be running on the test branch independent of master. So you can create changes in master, you can create changes in test, and they may not even cooperate together. You can merge it together, and I'll show you later how you can do that. But yeah, it's basically like two different timelines which you can access very easily on the same system. So like let's say your teammate is the only one who doesn't have access to that test branch or something, right? So what you did was you created a change in master, but you haven't committed it. So note that if you committed, then it will definitely stay on that branch. But let's say you haven't committed this change. Then what you can do is you can check out into the test branch. So git checkout test will allow you to access the test branch. And that creates this entire row, like this entire like change within the test branch. And then let's say you also committed after checking out. Then you can push your change to the test branch in the remote repository. And the remote repository will only record it in the test branch. It won't record in the master branch. Then you can create a pull request. So a pull request is like a system where you can combine two different branches and then you can merge them together. So you can also do that on Git itself, but usually people use pull requests because it's easier for you to visualize what the hell you're doing. So basically you have to create a pull request and then you have to merge, and that will create that same change on the master branch. Then your teammate can pull the new change onto the master branch. On the other hand, let's say like you guys really didn't communicate together or something, and you created a change in the test branch, and your teammate created a change on the master branch. What are you going to do, right? So basically, like, so you created so this is a non-committed change. Then you check out, and then you create a committed change. This is a committed change, right? And this is another committed change that your teammate has created in the master branch. How do you merge these? So basically, let's say your teammate is funny and he decides to push first, and then you pulled and got that change in the master branch, right? Then your local timelines altogether have very different very different changes already. So how do you fix that? Well, you can do this thing called git rebase. So git rebase master in the test branch will allow you to get all the changes in the master branch, and it will basically create that as the base of the branch. So basically how this works is that your master branch is like a static line, and then you're creating a branch, right? It's like it's a variant. So that branch itself will have it will be based on this specific temporal timeline in the master timeline, right? So all the changes before that will be reflected in your new branch. So if you created a new branch, then you have a base to go off. But if you, let's say someone made a change in the default branch, which is the master branch, then you can pull those changes and you can say, oh, that was originally already there, and I just created new changes after that. So Git is really powerful in that case. And then what you can do is you can push to the test branch on the remote repository. The remote repository will create, from there you can create a pull request and merge, and then your teammate will get the changes. So I won't show you how to install because I assume you've already done that, but I'll show you how to use this now. So basically, what you can do is you can write git status to git status, and this will show you like a summary of what your repository has. So for now, it only shows the untracked files because you haven't staged any, and because you haven't staged any. So to stage this file, as we know that we do git add note.txt. You can also just do git add dot. Dot basically adds all the files in the current directory and in subdirectories as well. So, but for now, let's just do note of these, right? what would you expect to see in the Git status? It's basically that it goes into this thing called the staging area. So this would be reflected by this changes to be committed. So to remove this, I can do git rm dash git node. Now if I open git status, it's back to where it originally is from. So that's like a system, and rm on its own is like used to delete files that you created that are worthless. So git, so like basically git rm is removing the cache that was generated when you added it into the staging area. I can continue using this. So I can git add dot git status again, and it's in the staging area, right? So how do I commit this again? I just do git commit and initial, right? Now I've created this commit called the initial commit. These are the first few characters of the commit, and this is what changes you've made in here. So yeah, basically like that's the new commit that you've created in initial commit. But then how does that make any difference? Well, basically what you can do now is if you go and open this and I type my name, you can see these green lines, right? And if I control S, same thing. These green lines are representative of like the changes that you've made. So if you open this and you just like if you just go here, then you can see that, oh, it's noticing that, oh, you've added these two lines. Now let's say I decide to be a bit stranger and I delete the hello world. Then what you will see in the change again is this. So you've deleted hello world and you've replaced it with my name is whatever this is. So yeah, basically this is called a working tree, and this shows you the changes that you've made in real time. So originally this was the original node, right? But this was the change you made to the original node, and this is the change you made after you already had the original node. So yeah, basically that's just how it works. So yeah, like I'm using node.txt now. Let's say I reintroduce hello world, but I do something like this. Or so then what it's doing, right, is it's deleting this line. So it's keeping this, but what it's deleting is this comma and this exclamation mark. And instead it's taking the full stop because I added the full stop. And then after that, it's also saying that, oh, this entire line has been created with my name is this. So that's like how the working tree analyzes your changes, right? So now let's say I've now made a change, but this is a track part, right? So what happens? Well, git status can tell you what has happened. It's saying that now there's a change in the working directory, which means it's a change that is in the tracked files, and you can now stage it again. You have to stage it. So I can do git add dot again. And if I go into git status, it will say there's a moment for it to be staged. And now instead of git rm, you have to do git restore. So restore would mean that you move it from stage to back because it's already something that was in the working directory. So let's say I don't want to do that. I'll just commit, right? So git commit m new words edit. So this is what we call a message. I'm not sure if I covered this, but basically the /m means message. And then this is like a string code notation where you indicate what message you want to keep here. So ideally the message should be helpful. It should be indicating what you've done with the commit, so that the person doesn't have to read every single change just to understand what you've done. So let's say I do this. So then you'll be able to see like this entire thing. But then it asks, why aren't you publishing the change, right? So if I now do like something like this, git log would show you all the commits you've made. So I created an initial commit today at 10:28, and I created a new commit today at 10:32. So these two commits were like basically they were recorded. They recorded what time I created the commit and what it also records like the zone time and everything. And it also records this thing called the commit like hash. I think that's what you call it. And then like who created it. For some reason, this is coming in, which I don't know why it's coming in, but I'll explain this to you guys later, I guess. So now, if I go and check Git status, it will say it's clean. So how can I now relate this to GitHub on its own? So let's say I open GitHub. So I've logged in and yeah, so basically GitHub has been, this account has been created. Now what I can do is I can create a new repository and I can name it, I don't know, I'll name it GitHub or something, right? So intro to GitHub. I'll leave it as a public repository. You can also choose to make it a private repository. It's just a bit difficult to access it because you need to verify credentials before importing it. So I'd use public for now. Since in the case where you haven't logged into your GitHub account in Git, don't add any of these files if you do this because well these files are like they create a commit on their own into the remote repository. Then merging becomes a big thing. So I'm just going to create an empty repository and copy the URL. And now what I can do is I can do git remote add origin this dot git. So git is the command. Remote means the remote repository. Add is that there's a list of remotes that you can keep and you're adding a new remote. Origin is the name of the remote that you're keeping in, and then this is your the name of like the where you can get this entire system, and you use .git to just like indicate that this is like a location from where you can steal all of this. Now I can press enter and the remote has been added. But because something that you need to note is that branches in GitHub on its own are initially started as main, not as master. Although Git itself creates the first branch that's created on Git is a master branch. So for some reason, I really don't know why, but GitHub is very strange in these concepts and it decides to change the name into main because some specific reason. I really don't know. It's like something related to, yeah, it's something related to slavery. So yeah, so I'm not going to cover that more, but it's basically you have to change the name of the main branch so that you can push your changes to remote. What I can do now is I can do git branch. So git branch on its own is how you can create branches, but /m main means you're changing the name of the default repository, default branch, sorry, and that makes the name main. It's basically like you're moving all the changes from master to main. So now it will be compatible with you to like push. So what I'm going to do is I will do git push u origin main. So when you're first pushing, you really need to indicate both this and this, everything. After this, you can just like write git push on if you're on this branch, but for now you have to indicate. So origin is the name of the remote, main is the name of the branch that you're setting this system for. U means set upstream, meaning that you should be, if you ever write git push on its own, you will have to write push to the origin. So unless of course you decide to like indicate which remote you're using. So git push u origin main, and I can press enter, and this will create some kind of system where it asks you to verify your account. So you can use a personal access token. How you can access it is like go here and in settings. I won't create a personal access token here because that's not a good idea. But you can go into developer settings and create your own personal access tokens here. But instead, what I'm going to do is I'm going to sign in using the browser. So this will just open this and it won't load for some reason and it will push. Now, if I go into the remote repository and I click like reload, you will find a node.txt. So this is how GitHub works, and it's a really cool system that it adopts. So now what I can do is I can open and I can see all the changes I made already. And I can also access the history of this file. And I can see all the commits that were made to this file. So I guess that's not really important, but it's mainly just to understand the system itself. Then I'll cover how you can use how merge configs work. So okay, so I read the comments from that you sent to Kimi. I think the issue that you're having is that when you copied the link, you had some initial characters that you need to delete. So if you're using this, you should be using you should not be having anything here. It just should be a space. So I hope that helps. But yeah, basically that's just how because I think Bash on its own is not able to sense a lot of the different changes that you make. So you have to do something like this. Yeah. So now that I'm on, I pushed all my changes to the remote repository. I guess I'll show you how conflicted Git can get when you're making changes. So if I create a README on this file, and let's say I keep it as GitHub into the GitHub. This is called Markdown, and it allows you to visualize your changes. So now I have a readme.md, right? But let's say I don't pull, and instead I create a file on here, which is also called readme.md. And I say in this intro to GitHub workshop for maybe here or something, right? Then what I can do now is I can look at git status and we'll say that there's a new file called readme.md added. I'll do git add dot git commit add new readme. And now I will do git push. Since I've already said the upstream, this should work. But here's the thing, it won't. Why? Mainly because you have a change on the master branch and you need to pull that first. So there's a priority in terms of how you can pull and push. So you have to pull any changes first before you can push, which is like a strange thing, but yeah. So now I'll do git pull. And what you'll see is this conflict add/add, which is basically saying, oh, there's a merge conflict here, and we need you to fix it. So this is what the merge conflict looks like. But if I open this on Notepad, it looks way worse. So if I use this and I just open readme.md, it shows up something like this. So it's a textual form of looking at it. You have this system where it shows what changes you've made. Then this equal sign represents a demarcation between what changes you've made and changes that the other person made. Then this is the changes that I made on GitHub, but obviously it won't record as changes I've made. And then leave this the commit message of that change. So what I can do here is I'll just show the different systems you can employ here. So there's accepting current change, which is the change that you've made, accepting incoming change, which is change that the other person made, accepting both changes, which is when you just merge it. So if I can just show you, this is accepting current change, this is accepting incoming change, and this is accepting both changes. This is like the way you usually go. So what I'm going to do is I'll accept current change, Control S. And now you'll see that there's something called this line coming in, right? This basically represents that some merge conflict has occurred and you have to fix it now. So if I go and check git status now, I can do git add dot git commit and fix change merge conflict in readme and git status git push. So as you can see, once I've committed, it already records that, oh, the merge conflict is not taking place anymore. And now it's fixed. That's pretty good. And that's something that GitHub allows you, Git and GitHub allows you to do very easily. And now that I've pushed it, I can see whatever changes I need to see on this system. So if I reload it, I'll see all the changes. So for some reason, I don't know why, but my account from this is accessing this. So just ignore it. I guess I haven't really set up this laptop very much. So yeah. So GitHub main. Now what I can do is, other than this, I can create my own like branch. So how I can create a branch is I can do git branch. What should be the name of the branch? I guess I'll use test. Now that I've created a branch, I think you can use git branch just to like see what branches are there. So there's the main branch which you're currently on as represented by the asterisk and test branch. So I can go into the test branch by doing git record. So now I'm in the test branch, and now if I make any changes, it's very difficult for you to like make the changes back in main unless you create a pull request. So like let's say I create a readme.py md right now. I'll create a hello.py and I'll say this is a demo Python for building. Then import anti-gravity. Anti-gravity is a module in Python. I'm not sure if you guys have used it, but just like it's a very useless module, but it's a funny thing to use, I guess. Then if I go into git status, it will show you that oh it's untracked now. So git add dot git commit add hello by git log. So in git log now you see add hello.py, but you also see the other changes that I made on the remote repository, which I made on origin main and main. And these are all changes I made originally on main, which have been pulled together into the test branch. So basically, like if it's a very long system of showing it, right, then you can click enter to see the next few lines, or you can write quick Q to quit. So basically, yeah, git log is pretty useful for you to understand how these systems work. Now, what you can do is you can make a pull request. What I'm going to do is I'm going to do git push u origin test. So this is important because as we mentioned before, testing does not really work like branching, like this setting of upstream is specific to the branch. So testing still needs to be indicated. So now I'm pushing these changes up. And now you'll see this link, right? So I'm just going to copy this link. And Control V, Control V. So this is what we call a pull request. Basically, it shows the changes that you've made between main and test. So like, for example, I added this file. So it's saying that, oh, this is my main commit that I've added, right? So what I can do now is I can name this something useful. It's like introduce Python support, right? And then I can just say anti-gravity or something, right? So now I can create a pull request, and this just creates the system which you can now merge. So I'm not going to show you how to use like CI/CD and everything, but it's like you merge config and you can confirm the merge, and it's automatically merged now. So that's pretty good, I guess. So now you can also delete the branch. I shall not, just for the sake of clarity. So now I guess what you can see now in GitHub itself, in the you'll see a hello.py file with the old changes itself. So, and if you go into the test branch, it will show that oh, it's now one commit behind mainly because test had the main had the merging capabilities and everything. Now, let's say I made a change here. Sorry, not in here. I created a change in hello.py in here. So I also decided to be funny and import this even was. So commit change, and I go here, and since I'm still in the test branch as we've seen, I create another change. Or I'm like another change module. Import right. So now I can do git status git push, sorry, git push. I think you can just use git push at this point since you set up stream. Oops, sorry, I didn't git commit and git add dot and git commit. Add the finger, right? And then I do git push. So now if I open that same pull request that I created originally, using this, I think should be in pull request. I shouldn't have closed this, but it's basically like it's saying it's closed because I merged. But yeah, basically now that I've merged it, I can create another pull request just for the sake of it, I guess. And the base is not test. So now that I've added this, it's basically saying that, oh, I have a new change in this, which is saying that, oh, instead of it just stopping at anti-gravity, you've added another strange model, which is the Kinto. So now I create a pull request, but it's saying it can't automatically merge. Why? Because of the merge conflict. So like, let's say I do add filter for no reason whatsoever, and I create a pull request. It will say that you can't merge it. So you can resolve the commits conflicts here. And basically it's going to say that, oh, what are you doing here, right? It's the same thing, but instead of showing the commit hash, instead of just showing the branches. So I'll use both of them. Both. Just remove and right. And now I can say mark as resolved. Commit merge. So this new commit is introduced, which is the merge conflict, merge pull request, confirm merge. So now I guess what the issue that will come up is if you go into here and you'll see the system, it's saying that it works. But if you go into test and you see the system, it may not show it properly. Actually, it should, but yeah, it should. So basically, the reason why this happens is, as I mentioned before, you're making a change in the master branch, you're making a change in the test branch, and you're trying to merge them without fixing the conflicts. So this is where a lot of issues come up in like multiple different systems, but that's why we use GitHub and all these tools are available for you to access it. So now I'll show you how to use issues. So issues are GitHub's answers to like, oh, this is I need to do this. So I'm going to create a new issue and I'm going to say Python to not supported. Firstly, I'll do this. I'll do git pull just to pull whatever changes I made on this branch. And what I'm talking about is basically that this branch here, right here, the Kinto, this thing is very different if your system is if your Python system is Python 2. Because if it's Python 2, it should be the Kinto. So it should be capital T. It's quite important, I guess, but yeah, it's something that it's like a convention of sorts. So now let's say I just I get so all the changes that I've already added into hello.py are not reflected on my new my main branch. But now I can say, oh, Python 2 is not supported. I'll submit a new issue. Then I can like write a description if I want. I can also just edit the description. And now I've created an issue. And now what you can do is I can like for example, I can assign this to myself, or I can assign it to anyone who's added to this repository. I can add a label, so like bug, documentation, duplicate, enhancement. This is a bug, so I'll add the bug label. Then I can create projects as well in the repository and everything. And everything will show on this. Milestones in development, I'll try showing how to use this. So create a branch for this issue. Python 2. Let's say I create a new branch called Python 2 and create branch. Now what I need to do is I need to do git fetch origin here. And it will create a new branch called origin/python2, which is now a Python 2 branch. So if I go into git branch list, it will it should ideally say Python 2 as well. I really don't know what's happening, but I guess you just need to check out Python 2. Then if I now do this, I guess it should work. Yeah, so now it says that Python 2 is in the list. So now I can check this out, and basically you can make the changes here, or I can just like delete the thing altogether. But it says, and it says that there's a new change. So git add dot and git commit and fix the insert issue by using and git push new origin. And now what I can do is I can access this specific pull request, and I can say, yeah, create pull request, merge pull request, confirm merge, lead branch. And then in issues, I can just go and say that this is, and then automatically your issue will also be closed. So that's like automated system that you can use. There's also actions. So like, since I'm using Python here, I guess I can show you how to use this. This is called like, basically it's called a workflow, and you can use like this. It basically uses the GitHub's own laptops on the server, like Ubuntu and everything, where it's like loaded already for you and can set up for you. So like it shows steps. So for example, install dependencies, it upgrades script to the newest installment. It can install your Flake 8 and PyTest for testing the files, and all of this as well. Then this running thing is like, it's basically saying some linting issues. Let's say I just say test Python file and Python hello.py. It is hello.py, right? Yeah. Okay. Then I can commit this, commit new file, and this workflow will be created. So while it's checking the workflow, I can also cover wikis. So wikis are like basically like systems where you can create pages. So welcome to the GitHub wiki. This is a workshop for June. Yeah. Okay. So then I can save this, and I have a wiki page. This is also now a GitHub repository, and you can keep adding pages. You can add a custom footer. You can add a lot of different systems that you really don't need. Then there's projects, and I can create a project. So there's either projects that you have on a local level, on your username level, or you can create projects like as Kanbans here. Like let's say I create a project called intro to GitHub lead project for BBCS 2022. And I create the template based on automated Kanban. Then it creates these 3 columns where you can save whatever issues you have. So lead mode. This is very annoying. Delete mode. Delete mode. And I can just like look at this, and I can pull this issue and say it's done. So the Python 2 issue and its linked pull request will show up here. So it's like how projects works. Now to show what the actions did till then, it basically ran these files. It ran all the systems, and it said that, okay, nothing happened here. It shouldn't have happened. Nothing should have happened. Yeah, basically it just prints this this thing. So yeah, it's just the normal GitHub system. So that's how actions work, and it's like an automated workflow for you to check if there's any issues with your code. So yeah, that's basically how GitHub works. You have these different systems, and you can also create different repositories. You can access, you can create gists, which are smaller repositories. You can create projects on your username level. I can also show you the like the expansions that you can get to with GitHub with other account. This is my main account, which I don't use more. So like you can create your own README. So this can be done like, sorry, I think I screwed up. Okay, it's fine. We have 2 minutes left, so I'll speed run through whatever I can. Right. Then I can create this new repository on my side called Spiderwiz. Oh wait, sorry. But basically, yeah, it's like I think I forgot to delete it before the repository before this, but it's fine. So basically, you can create this Spiderwiz and create a README, and that will show like a README here. So that's like something powerful that GitHub recently introduced. It's called the Propel README. And other than this, there are organizations. So like BuildingBloCS has its own organization, if you're curious. Adventure, which is the CS interest group, and NUSI. And different systems that you can create. So this is like Astronomy Club and everything. So and these are like analytics that you can generate using Git, and these are cards you can generate using Git. These are projects you can work on. You can it will show like the dominant system. There's also like systems for you to star repositories. So if you're being deliberately provocative, you can just start your own repository. You probably shouldn't do that, but a lot of people do that for some reason. So yeah, watching and unwatching is like to see what activity has taken place on this repository and everything. So that's just how it works. Other than this, I guess one last thing that I can cover is pages. So pages are like basically it's a system which GitHub introduced quite a while back, and it's one of its most used features. So like let's say I select the hacker team, and I just like create an index.md or something. Intro to getting GitHub and introductory workshop or then I can commit this change. And now, after a short while, basically it would take a short while, and then it would just deploy this onto like GitHub pages. So it will take some time, but overall, once it's done, it will create a README file for you here, HTML file for you there, and you can see whatever changes you need to make. So I think it takes some time because well, it's accessing an entirely different system. It's rendering it slowly, so it's another workflow as well. So it takes a bit of time, I guess. So like it's doing the report build status, and it's like this is called jobs in the actions. It's like a complex way of you just like introducing different changes, and then it all works different separately. So yes, I guess now if I open this is introduced. So yeah, that's like a introductory workshop for Git and GitHub. I hope you enjoyed. I can stay here for a while to like flag any questions if anyone has. Until then, thank you for listening, I guess. Yeah.